and welcome to Dora Insights. As I was sharing in my demo, with Dora, you are getting actionable insights. Opsera is a great way of measuring these insights, and we provide it out of the box. We have these 4 KPIs like the deployment frequency, lead time to change, time to restore service, change failure rate, that will help you measure across the developer experience, stability, throughput, velocity, and agility. Once you have connected these tools like ServiceNow, Jira, GitHub, GitHub Actions Pipeline, we will be able to populate these Dora KPIs. From the left side, I'm going to show you how I landed on this Dora dashboard. From the left side, go to homepage, and this is toolchain, which is an independent microservice. There's pipeline, another independent microservice, similarly insights and insights dashboard. We are based on microservice architecture. When I click Insights, Next Gen, I land onto my dashboard. Dora dashboard. Now you can see all the metrics at one place. And imagine when you go to Agile Sprint Planning or Scrum meeting, you're able to see this valuable data to make informed decisions or see an overall picture of your entire line of business. We follow the same industry standards and categories like you can see here: elite, low, medium, high. And first, let's go into the first one, that is deployment frequency. We can go drill down into further how often your organization deploys code to production. And here in the graph, I can see there were successful deployments of 363. Further down, I can see total number of deployments. You can see current time taken to deploy, total deployment failed, and average time to restore from failed deployments. Furthermore, you can see what was the check-in, where the check-in happened. You can see the branch and when the build was triggered, and you can see it took around 28 seconds to deploy. Also, we give you the link where you can go to your GitHub commit code, or in this case GitLab. With deployment frequency, you can see that are you improving or going down, how good you are doing with successful or failed deployments. You don't have zero downtime after deployment. Evaluate a strategy if there's a downtime. You can optimize after seeing this data. For example, your goal could be to reduce the average time to restore the failed deployments and see that your deployment frequency is going as planned without any failures. Also, you're able to see the correlation and contextualization that we go through our data transformer that is patented to Opsera. You can see the link for each commit. And this is an interesting extraction, correlation, and visualization architecture. Now let's go further to lead time for changes. How long does it take for a code commit to successfully run in production? And here we have a smooth graph to show that. And as you can see, it's improving for this organization. You can see total number of commits, total number of repos that were touched, the contributors, mean lead time, and the average lead time for first commit to each deployment. And further, similarly, you can see what was the commit and who made the commit, and it took about 138 days in this case, and in 86 days in this case for commit lead time. And again, similarly, you can get the link to the ticket ID and your commit. Now I will go to change failure rate. Now let me go to change failure rate. What percentage of changes to production results in degradation of service? What does it look like for the org? Once you know, then you can remediate this accordingly. For example, here their total number of 2 changes in a day, and then you have the list of defects, and similarly what was the when was it created and how much time it took to resolve. That was 3 days in this case. Do you require a hot fix or rollback or fix forward or a patch? Now the leadership team has a full view and give guidance accordingly. Let me go to mean time to resolution. How long does it take to restore a service when an incident occurs? Is it an unplanned outage or a service impairment? Similarly, we get the number of incidents that happened. You get a list, total number of incidents and total number of resolved incidents. Furthermore, you can see how long it took to resolve the incident. Was it the severity, medium, high, low? Who helped resolve it? And the link for the incidents that you can go to your Jira. Now let me go to cycle time for changes. In cycle time for changes, you can see that it took 13 days for design time. Then there was 10 days that was used to pick up the change, and then there was 13 days for coding time, and then a completion of around 7 days. And we can further drill down into this, which is going further, and I can look into each developer. For example, here issue assigned were 4 and issue completed were 4. For example, here the issue assigned was 1 and completed was 1. Similarly, you can see there were around 26 for this developer and 26 issues completed, and it took around 18 hours. You can also understand why it took 18 hours. For example, was it a regression issue? Was it an integration issue? And you can make optimized insights as a leadership team. Now, having said that, we also have Hummingbird Digest that will take all the 4 KPIs, and we can tell why one KPI is elite and the other is low. The AI-based influence we can provide how your overall developer experience, how your overall process. We provide the inference, like your lead time went up and your deployment frequency went down because we did not see any developer commit or not in the organization. And last but not the least, security. We are a secure SOC 2 compliant company. We have SSL TLS 1.3. You can have a dedicated tenancy and you'll get your own database. And we secured the secrets to HashiCorp Vault, which is an industry standard. And thank you. That was it for the Dora dashboard.